Hello everyone, a warm welcome to my YouTube channel, The Real PCC. My name is Pramodh Narain and I am your host for today. I am excited to take you through my Python Mega Project 1. Before we dive in, let me introduce you to my channel name and what it represents. PCC stands for Promote Code Crafter, a reflection of my deep interest in computer science, programming, data science, and technology. This channel is my way of sharing my knowledge and passion for these fields. Today's presentation is titled 2020 COVID-19 Global Impact Visualizer. This project leverages the power of Python and data science to analyze and visualize the impact of COVID-19 pandemic. We will explore how Python enables us to process, analyze, and present data driven insights through visualization techniques. This project is not just about numbers, it's about understanding the global impact of COVID 19 through the lens of technology. We will analyze key trends, discuss findings, and see how Python makes complex data clear, actionable, and insightful. So, without further ado, let's get started. Before we move in to the core sections of this project, I want to take a moment to express my heartfelt gratitude to those who made this journey possible. First and foremost, I extend my sincere thanks to my parents who have been my pillars of strength. Their constant encouragement, unwavering support, and belief in my abilities motivated me to complete this project with dedication and passion. Throughout this journey, they inspired me to push my limits and explore the endless possibilities of programming. This project wasn't just about writing Python code, it involved problem solving, patience, and continuous learning. During this process, I encountered challenges that required troubleshooting, debugging, and refining my approach. In those moments, my parents' support helped me stay focused and committed to achieving my goal. To my mentors, professors, and fellow learners, I express my gratitude for their guidance and insights that contributed to shaping this project. Every discussion, feedback, and resource played a crucial role in making this project a success. This project is dedicated to everyone who believes in the power of learning and innovation. Thank you for your support, and let's continue this journey together. Moving on, let's now take a deeper look into what this project entails, starting with its abstract and objectives. Python is one of the most versatile and powerful programming languages, playing a crucial role in both computer science as well as data science. This project showcases Python's capabilities by implementing a data driven approach to analyze the global impact of COVID 19. The primary goal of this project is to demonstrate Python's application in data science, particularly in processing large datasets, extracting meaningful insights, and visualizing trends effectively. We will cover a comprehensive breakdown of Python's fundamentals and real world applications, a hands on demonstration of Python's data visualization capabilities, and finally, the role of Python as a stepping stone to AI and big data analytics. This project isn't just about coding, it's about using Python as a tool to decode real world events, identify patterns, and make data driven predictions. By the end of this session, you will have a clearer understanding of how data science and Python come together to create impactful solutions. Now that we have an overview, let's explore the history and evolution of Python to understand why it's the language of choice for this project. Python was created by Guido van Rossum in 1991, and over the decades, it has become one of the most popular programming languages worldwide. But what makes Python so powerful and widely adopted? Python is known for its simplicity, readability, and efficiency. It has an extensive range of libraries that support various domains such as web development, artificial intelligence, automation, and data science. Compared to other programming languages, Python stands out due to ease of learning. Its intuitive syntax makes it beginner friendly. Versatility. It is used across multiple fields from software engineering to machine learning. Cross platform compatibility. Python can run on various operating systems without modification. In this project, we leverage Python's ability to process, visualize, and analyze data effectively. Now, let's dive into how Python is specifically used in computer science applications. Python is widely used in various fields of computer science. Let's explore its major applications. Software development. Python is extensively used for web, desktop, and game development. Frameworks like Django and Flask make web development seamless, while Pygame is widely used in the game development. Artificial intelligence. Python is the backbone of AI technologies. Libraries like TensorFlow, scikit-learn enable machine learning, deep learning, and NLP, that is, natural language processing, helping to create AI driven applications. Automation. Python simplifies file management, web scraping, and scripting. With libraries like Selenium and Beautiful Soup, it automates tasks such as web data extraction and repetitive system operations. Data structures and algorithms. Python is an excellent language for problem solving with built in data structures like lists, dictionaries, and sets, making it easier to implement efficient algorithms. Now that we have seen Python's applications in computer science, let's transition into Python's role in data science, where it is used for large scale data processing and analysis. Python plays a vital role in data science, offering powerful libraries and tools that simplify data handling, analysis, and visualization. Key libraries. Python provides essential libraries such as pandas for data manipulation, NumPy for numerical computations, matplotlib and seaborn for data visualization, and scikit-learn for machine learning models. Data pre-processing and cleaning. Handling missing values, normalizing data sets, and ensuring data consistency are critical steps in data science. Python enables efficient pre-processing techniques to clean raw data for accurate analysis. Visualization techniques. Using charts, histograms, and heat maps, Python allows data scientists to uncover trends and patterns in data sets, making complex information more interpretable. Real world applications. Python is widely used in various industries such as finance, healthcare, and marketing, helping organizations make data driven decisions and improve operational efficiency. Now that we understand Python's significance in data science, let's move forward to the project overview, where we will explore the objectives, data sources, and methodology of this project. The COVID-19 Global Impact Visualization Project aims to analyze and visualize the impact of the COVID-19 pandemic through Python based data science techniques. Objective. The main goal of this project is to analyze and visualize COVID-19 data, helping to identify key trends and patterns in the spread of the virus. Data source. The dataset used for this analysis is sourced from Kaggle's COVID-19 dataset, which contains detailed information on case numbers, deaths, recoveries, and active cases worldwide. Metrics covered. The project examines various key metrics, including total confirmed cases and daily new cases, reported deaths and recovery trends, active cases and case distribution by country, pattern trends and patterns and trends in the data over time. By leveraging Python's powerful data science libraries, This project provides valuable insights into the pandemic's progression. Now let's move forward to explore how we analyze new cases and daily confirmed cases using Python. One of the most critical aspects of understanding the COVID 19 pandemic is tracking the number of daily new confirmed cases. This metric helps researchers, healthcare officials, and policymakers gauge the virus's spread over time. To analyze daily new cases, a Python script is used for trend analysis where data is extracted from the Kaggle COVID 19 dataset. The script processes and organizes the data to calculate daily increases in reported cases. Time series analysis is performed to identify peaks, surges, and declining trends. To make these trends more comprehensible, graphical representations are generated using Matplotlib and Seaborn. These graphs showcase the fluctuations in daily case numbers, a comparison of case trends across different countries, the effectiveness of containment strategies over time. By visualizing these insights, we gain a deeper understanding of how COVID 19 evolved globally and how different regions responded to outbreaks. Now that we have examined the trend in daily new cases, let's shift our focus to an equally crucial aspect: daily reported deaths due to COVID 19. While tracking daily new confirmed cases gives us insights into the virus spread, it is equally important to monitor the number of daily reported deaths. This metric helps us understand the severity of the pandemic and the effectiveness of healthcare interventions. To analyze daily death trends, a Python script is used for data extraction and processing. The script retrieves daily death records from the Kaggle COVID 19 dataset, organizes the data to calculate and visualize trends over time, identifies peak fatality periods and declining mortality rates. Graphical representations are created for this project by using Matplotlib and Seaborn, which allows clear visualization of fluctuations in daily death numbers, regional comparisons to highlight areas with high mortality rates, insights into how different policies and healthcare responses impacted death tolls. By studying these trends, we can assess the pandemic's worst hit periods and how various containment strategies influenced mortality rates. Now that we have examined the trends in daily reported deaths, let's move to a more positive aspect: daily COVID 19 recoveries and how they signify the progress in the pandemic control. While tracking new cases and fatalities provide insight into the severity of the pandemic, analyzing daily recoveries is equally important to understand the healthcare system's effectiveness and the progress towards overcoming the virus. This project uses Python scripts to track and visualize daily recovered COVID 19 patients. The script processes data from the Kaggle COVID 19 dataset, calculating the number of recoveries each day. The analysis helps in identifying trends in recovery rates across different regions, understanding how medical advancements and treatments have improved recovery times, comparing recovery patterns with new cases and deaths to measure healthcare responses. To make this data visually interpretable, graphical outputs are generated using Matplotlib and Seaborn. These graphs provide a clear representation of daily recoveries over time, comparisons between different countries to evaluate healthcare performance, insights into how vaccination campaigns and treatment availability influenced recovery rates. Tracking recovery trends is essential in determining whether a country is successfully managing the pandemic. Now, let's shift our focus to active cases by country or region, where we analyze the number of ongoing COVID 19 infections in different parts of the world. Understanding active COVID 19 cases is crucial in assessing the ongoing impact of the pandemic. Unlike total cases, active cases represent the number of people currently infected, excluding recoveries and fatalities. Tracking this metric helps in identifying hotspots that require immediate intervention. In this analysis, Python is used to track active cases across multiple countries and regions, perform comparative analysis of countries with highest active case counts, highlight patterns of increasing or decreasing active cases over time. To visualize these trends effectively, we generate graphical trends using Matplotlib and Seaborn. These charts help in identifying which regions are experiencing rapid growth in active infections, analyzing whether containment measures have been effective, predicting future surges based on the past trends. By continuously monitoring active cases, governments and healthcare organizations can allocate resources efficiently and implement timely interventions. Now that we have examined active cases, let's move forward to analyze the daily new COVID 19 cases and how they impact ongoing trends. Tracking the daily trends of new COVID 19 cases globally is essential for understanding the pandemic's progression and identifying areas requiring urgent intervention. By analyzing these trends, we can determine the effectiveness of containment measures and predict potential surges. To achieve this, Python based visualization techniques are used to compare trends across different regions. This involves collecting real time data from sources like the Kaggle COVID 19 dataset, utilizing pandas and NumPy to pre process the data and extract key insights, applying Matplotlib and Seaborn to generate interactive line graphs and bar charts that display daily case trends. These graphical insights allow for effective monitoring by highlighting peak infection periods in various countries, enabling comparative analysis between different waves of the pandemic, providing data driven decision support for governments and healthcare organizations. By leveraging Python's powerful visualization tools, we gain a clearer picture of how the virus spreads and how different regions have responded over time. Now that we have examined daily case trends, let's move on to another crucial aspect, daily new deaths due to COVID 19, which provides a deeper understanding of the pandemic's impact. Just as tracking new confirmed cases is essential, monitoring the number of daily reported deaths due to COVID 19 provides valuable insights into the severity and impact of the virus. This metric helps in assessing the effectiveness of healthcare systems and containment measures. To analyze daily new deaths, a Python script is implemented to extract and process the latest fatality data from the Kaggle COVID 19 dataset, identify patterns in mortality rates across different regions, conduct trend analysis to observe spikes and decline deaths over time. To effectively visualize this data, we use Matplotlib and Seaborn for graphical representation. The visualizations highlight the variation in daily reported deaths worldwide, a comparison of death rates among different countries, the impact of medical interventions and vaccination programs on reducing fatalities. Understanding daily new deaths allows us to evaluate the pandemic's deadliest phases and determine which strategies helped mitigate its effects. Now that we have analyzed the trends in daily COVID 19 deaths, let's move on to a more hopeful statistic, daily new recoveries. Understanding the daily recovery rate from COVID 19 is just as crucial as tracking the new cases and deaths. This metric gives insights into the effectiveness of treatments, healthcare responses, and vaccination programs in different regions. To analyze daily recoveries, a Python script is used for data extraction and trend analysis, where data is pulled from the Kaggle COVID 19 dataset. The script processes and organizes recovery data, calculating data based on daily increases in the recovered patients. Comparisons between different countries and time periods help identify regions with higher recovery success rates. To make these trends easily understandable, graphical representations are created using Matplotlib and Seaborn. These visualizations display fluctuations in daily recovery rates, how medical interventions improved recovery over time, the impact of vaccinations and healthcare advancements on survival rates. By analyzing recovery trends, we gain a better understanding of how different nations handled patient care and improved recovery rates during the pandemic. Now that we have explored daily recoveries, let's shift our focus to another vital measure, which is deaths per 100 cases, which helps us understand the severity of the virus in relation to confirmed infections. One of the most critical indicators of the severity of the COVID 19 pandemic is the proportion of deaths per 100 confirmed cases. This metric helps assess the mortality rate and provides insights into how different regions managed the pandemic. To analyze this, a Python script was developed that extracts real-time data from the Kaggle COVID-19 dataset, calculates the death rate per 100 confirmed cases for various countries, identifies trends over time to understand how mortality rates changed with different containment measures and medical advancements. To enhance clarity, Matplotlib and Seaborn were used to create graphical representations that compare death rates across multiple countries and regions, highlight fluctuations in mortality rates over time, provide a clear picture of how various healthcare systems responded to critical cases. By analyzing these insights, we can determine which countries had higher fatality rates and investigate the factors that contributed to them, such as healthcare accessibility, hospital capacities, and vaccination efforts. Now that we have examined the mortality rate, let's move on to a more optimistic metric, the proportion of recoveries per 100 confirmed cases. Understanding the proportion of recoveries per 100 confirmed cases provides valuable insights into the effectiveness of healthcare responses across different regions. The higher recovery percentage often indicates better medical infrastructure, early intervention, and successful treatment protocols. To analyze this metric, a Python script is used to extract recovery and confirmed case data from the Kaggle COVID 19 dataset. Compute the ratio of recoveries per 100 confirmed cases. Identify trends and regional variations in recovery rates. To make these insights visually engaging, Matplotlib and Seaborn are used for graphical representation, which helps in comparing recovery rates across different countries, identifying regions with high and low recovery proportions, observing how recovery rates evolved over time as treatment methods improved. Analyzing recovery trends helps governments, researchers, and policymakers evaluate the success of different COVID 19 management strategies. Now that we have examined recovery proportions, let's summarize the key COVID 19 data across multiple countries to get a broader perspective on the pandemic's global impact. To gain a comprehensive understanding of the pandemic, it is essential to compare COVID 19 trends across multiple countries. This section provides a summarized analysis of key COVID 19 metrics, including total cases, deaths, recoveries, and active cases, helping us observe how different regions were affected and how they responded. A Python script was developed to automate this analysis, where data from multiple countries was aggregated and processed using pandas. Statistical comparisons were performed to highlight countries with the highest and lowest case counts. The effectiveness of pandemic response strategies was inferred based on the trends in case numbers and recoveries. To present these findings visually, we use Matplotlib and Seaborn to create bar graphs and line charts illustrating the case distributions, comparative heat maps to highlight regions with the most significant impact. Trend lines showing case progression over time. These visualizations allow us to easily interpret large scale data, identifying patterns, and making data driven inferences about global pandemic trends. With this summary, we have gained valuable insights into the global impact of COVID 19 through comparative analysis and visual representations. Now, let's take a closer look at the actual Python output, which showcases the total counts of COVID 19 data. This will help us understand how the script processes the data and generates meaningful results for further analysis. To get a complete picture of the pandemic, it is essential to analyze the total counts of key COVID 19 metrics. This includes confirmed cases, deaths, recoveries, and active cases worldwide. By aggregating this data, we can identify broad trends and patterns in the virus's spread and impact. A Python script was implemented to extract and process data from the Kaggle COVID 19 dataset, compute total counts for each key metric, organize the data efficiently for visualization and further analysis. For better understanding, the results were visualized using Matplotlib and Seaborn, allowing us to compare total cases across different time periods, analyze which regions reported the highest and lowest case counts, track the global progression of the pandemic over time. These total counts provide the foundation for deeper analysis, leading us to an important aspect understanding the average death rate and recovery rate, which offers critical insights into the severity and management of the pandemic. Next, we will explore the Python generated summary of death and recovery rates, helping us measure the effectiveness of healthcare responses worldwide. Understanding the average death rate and recovery rate across all countries is crucial in assessing the severity and impact of COVID 19. This analysis provides key insights into how different regions handled the pandemic and the effectiveness of their healthcare systems. To perform this analysis, a Python script was used to extract COVID 19 case data from the Kaggle COVID 19 dataset, compute the average death rate from calculating calculating the ratio of deaths to confirmed cases, compute the average recovery rate by analyzing the proportion of recovered cases, compare trends across multiple countries, and identify key patterns. To visualize these findings, Matplotlib and Seaborn were used to generate graphical representations. These graphs highlighting these graphs highlight variations in death and recovery rates across different nations, showcase patterns over time to understand healthcare responses, provide a comparative view of countries with higher or lower recovery rates. By analyzing these statistics, we gain a clearer picture of which regions had better survival outcomes and where improvements were needed. Now, as we move forward, we take a closer look at the raw dataset that powered our analysis. It's time to dive into the Excel screenshots section, where we delve into the first dataset snapshot to uncover the foundational data driving our analysis. Get ready for an exciting and hands on look at the data that fueled this project. Now, let's take a deep dive into the first dataset snapshot, which provides the most up to date and comprehensive COVID 19 statistics for various countries and regions. This dataset serves as the foundation for our analysis, helping us track and interpret global pandemic trends with accuracy. Within this dataset, we focus on key metrics such as confirmed cases, the total number of reported infections, deaths, the count of fatalities attributed to COVID 19, recoveries, the number of patients who have successfully overcome the virus, Active cases, the ongoing infections still under medical observation. On the slide, you will notice a sample image of the dataset, giving us a glimpse into the structured format of the data. This spreadsheet contains rows and columns that categorize each country's statistics, making it easier to extract meaningful insights. Analyzing such a well structured dataset allows us to identify patterns, compare different regions, and observe how the pandemic evolved over time. Now, building upon this dataset, we move forward to explore another important data representation, a structured 2D format that maps confirmed cases effectively. Let's take a look at the next dataset snapshot. Now that we have explored the initial dataset snapshot, let's move ahead and examine a 2D area chart that represents the relationship between country, region, and confirmed cases of COVID 19. This visualization allows us to understand how cases were distributed globally and identify regions that were most affected during different phases of the pandemic. In this analysis, the data set is structured to map each country or region against its confirmed COVID 19 cases. The 2D area chart is used to visually highlight trends and patterns, making it easier to compare countries at a glance. The graphical representation provides a clear perspective on how cases escalated over time and varied between nations. If we take a look at the sample image displayed on this slide, we can see how the dataset is arranged in tabular form, capturing each country's confirmed cases. This structured approach enables Python scripts to efficiently process and generate meaningful insights from the data. By leveraging these situations, By leveraging these visualizations, we gain a broader perspective on how the virus spread across different parts of the world and how certain regions experienced significantly higher case surges than others. Moving forward, let's take a similar approach in analyzing COVID 19 deaths. The next section introduces a dataset that provides 2D visualization of reported deaths globally, giving us further insight into the pandemic's impact. Moving forward in our dataset exploration, we now analyze total deaths due to COVID 19 across various countries and regions. To visualize this effectively, we use a 2D area chart that provides a comparative overview of the mortality rates worldwide. This sheet, as seen in the sample image displayed on the slide, presents country wise total deaths, highlighting the regions most affected by the pandemic, a clear mortality trend allowing us to identify countries with higher fatality rates. Comparative insights helping us understand how different nations responded to the crisis. By leveraging this data, we can observe how mortality patterns evolved over time, indicating the effectiveness of healthcare interventions, vaccination efforts, and government policies. Now, as we move ahead, let's shift our focus to a more optimistic perspective. The next dataset snapshot highlights recovery trends, where we explore the 2D area chart for recovered cases across countries. Let's take a closer look at how different regions manage to bring recovery rates up. Now, let's shift our focus to an essential aspect of the pandemic: global recovery trends. Understanding the number of recovered cases helps us assess the effectiveness of medical treatments, vaccination drives, and healthcare responses worldwide. This slide presents a 2D area chart visually illustrating the relationship between countries or regions and total recovered COVID 19 cases. This graphical representation allows us to observe how different regions progressed in terms of recovery. Compare countries with higher recovery rates versus those still struggling. identify patterns in recoveries over time. Additionally, as seen in the Excel sheet snapshot displayed on this slide, the dataset provides structured data that feeds into this visualization. It highlights key numerical values that drive the 2D area chart, ensuring accuracy in trend analysis. By analyzing this chart, we can see which regions had successful recovery strategies and how recovery numbers evolved over time. Now, let's explore another key dataset visualization, the 2D area chart tracking active COVID 19 cases across different countries and regions. This visualization is essential for understanding the current load of infections in the worldwide level, helping us analyze which regions have higher ongoing cases and which are recovering. In the Excel snapshot displayed on the slide, we can see how the dataset organizes active cases by country, highlighting trends in real time. This structured data allows us to identify countries with high active cases, signaling critical healthcare pressure, track gradual reductions in infections, showing successful containment efforts, observe regional disparities, providing insights into global pandemic management. By representing this information through a 2D area chart, we achieve a clear visual representation of how different countries are managing their active cases over time. Now, as we continue exploring the dataset, we shift our focus to another significant metric, which is newly reported COVID 19 cases. In the next section, we will analyze the 2D area chart for the new cases, which offers a deeper insight into how fresh outbreaks are unfolding worldwide. Let's dive in. Now, let's explore the 2D area chart that represents the relationship between country or region and new COVID 19 cases. This visualization provides a clear picture of how different countries experienced surges in infections at various points in time. In the Excel sheet shown on this slide, we can see how the dataset is structured. It contains numerical values that are processed and visualized using Python. The 2D area chart effectively highlights the rise and fall of daily new cases in different regions, patterns in infection spikes and declines, the impact of various containment strategies across countries. This visualization tool allows us to identify trends and compare which countries saw rapid increases or slow declines in new infections. As we move forward, let's take a similar approach but shift our focus to an even more crucial aspect, tracking new COVID 19 related deaths. This next data set will give us insights into fatality trends across different regions, helping us understand the severity of outbreaks in various parts of the world. Now, let's shift our focus to one of the most critical aspects of the COVID 19 pandemic, new deaths reported across different regions. This dataset provides a structured look at how fatalities fluctuated over time in various countries, helping us identify patterns and trends. To visualize this data effectively, a 2D area chart has been created. This chart represents the daily and periodic rise in COVID 19 deaths, highlights how different countries experienced waves of fatalities at varying intensities, allowing us to compare regions and analyze the severity of the pandemic's impact globally. On the slide, you can see a sample image of the dataset showcasing the raw numbers recorded for new deaths in different regions. This structured dataset serves as the foundation for generating meaningful insights and accurate visual representations. By analyzing this chart, we gain a clearer perspective on mortality trends, which countries experienced spikes when the peaks occurred, and how interventions may have influenced the patterns. As we continue exploring the dataset, our next step is to focus on the recoveries. Moving forward, let's analyze the 2D new recovered data to analyze to understand how recovery rates evolved across different regions, shedding light on the positive side of the pandemic's trajectory. Now, let's shift our focus to the pace of recovery across different regions as new cases begin to decline. This sheet presents a 2D area chart offering a clear visual comparison of country or region versus new recoveries after the peak of COVID-19 attack. The dataset in the image displayed on the slide provides structured insights into how quickly different regions recovered from the pandemic, the correlation between declining new cases and rising recoveries, patterns that help assess the effectiveness of healthcare systems worldwide. This visualization allows us to observe which countries experienced faster recoveries and how the rate of recovery evolved over time. The shaded regions in the 2D area chart make it easy to identify trends and compare regions effectively. By analyzing this, we gain valuable insights into the resilience of healthcare infrastructures, government interventions, and medical advancements that aided recovery. Moving forward, we now examine another crucial statistic, the number of deaths per 100 confirmed cases. Let's take a detailed look at the next dataset snapshot, which highlights global variations in fatality rates. Now, let's take a deeper dive into how mortality rates compare across different regions using a 2D area chart. This visualization helps us understand the number of deaths per 100 confirmed COVID 19 cases across various countries and regions. Displayed on the slide, we have a sample snapshot of the dataset, which serves as the foundation for this analysis. This data set includes a list of countries or regions, the number of confirmed cases, the corresponding death rate per 100 cases. Using Python, this data was processed and visualized as a 2D area chart, allowing us to see clear distinctions between regions with higher and lower mortality rates. The chart highlights countries that struggled with higher fatality rates, regions that managed to keep death rates relatively low, emerging patterns that indicate better medical infrastructure and response effectiveness. By interpreting these insights, we can see how different regions fare in handling severe COVID 19 cases. Moving forward, we now shift our focus to recovery rates, an equally important metric. In the next section, we will explore the 2D recovered per 100 cases dataset, which provides a clear perspective on how well different regions managed patient recoveries. In this section, we analyze the recovery rate per 100 confirmed COVID 19 cases across different countries using a 2D area chart. This visualization helps us understand how well different regions responded to the pandemic in terms of patient recovery. The dataset provides a breakdown of the number of recoveries per 100 confirmed cases for each country, a comparative analysis of regions with higher versus lower recovery rates, trends in recovery rates offering insights into healthcare effectiveness across nations. Displayed on the slide is a sample image of the dataset sheet, which showcases the structured data used for this analysis. This spreadsheet contains detailed numerical values that were processed to create the 2D area chart, helping us visualize recovery trends more effectively. By leveraging Python's matplotlib and Seaborn, this chart provides an intuitive way to compare recovery success rates globally. Such visualizations play a crucial role in highlighting the efficiency of medical interventions in different parts of the world. As we conclude our analysis of recovery rates, it is time to broaden our perspective and explore the bigger picture of COVID 19 trends. In the next section, we'll dive into COVID 19, trends and insights, and the road ahead, where we uncover key takeaways from our data driven exploration. Get ready for a deep and insightful discussion on the past, present, and what the future holds in the fight against COVID 19. As we analyze the global impact of COVID 19, several key insights emerge. Cases have continued to rise in waves, affecting regions differently. Some areas experienced higher fatality rates while others had better healthcare responses. Recovery rates have shown steady improvement thanks to enhanced treatment protocols and widespread vaccinations. When looking at trends, we observe vaccination success has drastically reduced severe cases and fatalities. Seasonal surges and new variants have influenced the overall case trajectory. Case recovery patterns have shifted, with some countries recovering faster due to early interventions and medical advancements. Moving into the future, COVID 19 is expected to transition into an endemic phase, meaning more people will be vaccinated, leading to improved immunity over time. Localized outbreaks may still occur, requiring quick response measures. Governments will focus on long term management strategies rather than emergency responses. Ultimately, the key to a safer future lies in the data driven decision making. By continuing to analyze trends, governments and organizations can develop proactive strategies to mitigate risk and protect communities. Now, as we approach the final segment of this presentation, let's shift our focus to the conclusion and future scope, where we reflect on the key takeaways and discuss how this project can be expanded further. As we reach the conclusion of this project, let's reflect on the key findings from our data analysis. Through Python's driven insights, we identified global trends in COVID 19 cases, deaths, and recoveries, allowing us to assess the effectiveness of different public health responses. Key findings: the fluctuations in daily cases and deaths highlight the very varying impact of COVID 19 across regions. Countries with strong healthcare infrastructure and early intervention strategies saw higher recovery rates and lower fatality rates. Data visualization played a crucial role in interpreting pandemic trends, helping policymakers make informed decisions. Recommendations: strengthening public health preparedness through real time data analysis, using predictive modeling and AI to forecast potential outbreaks and mitigate risks, encouraging open source collaboration for data transparency and global research efforts. Future research directions. The power of AI, deep learning, and big data analytics in healthcare will continue to grow. Future research can focus on automated disease prediction models for early outbreak warnings, AI driven patient monitoring systems to enhance medical responses, big data frameworks for handling large scale health records efficiently. The integration of advanced technologies will shape the next era of global health preparedness, ensuring we are better equipped for future pandemics. Now, as we wrap up, let's take a moment to acknowledge the valuable references and data sources that supported this research in our bibliography and references section. No research or project is complete without acknowledging the invaluable data sources that contributed to its success. In this case, our analysis was powered by the Kaggle COVID 19 dataset, which provided real world data on confirmed cases, deaths, and recoveries across various regions. A huge thanks to Kaggle for making open source datasets available to researchers, students, and professionals worldwide. The transparency and accessibility of such data allow us to gain meaningful insights and develop impactful solutions. For those interested in exploring the dataset further, you can access it to the reference link provided in the description section of this YouTube video. By leveraging data from sources like Kaggle, we ensure that our findings are grounded in factual, up to date information, making our analysis more reliable and insightful. With this, we wrap up the technical aspects of our project. But before we conclude, let's take a moment to reflect on the journey so far, the challenges, the learnings, and the next steps. However, this is not the end, this is just the beginning. The journey of exploring, learning, and creating continues, and so will future projects. With that in mind, let's step into our final segment. The journey continues. As we bring this incredible journey to a close, let's take a moment to reflect on what lies ahead. Displayed here is an image of a winding road leading to a radiant sunrise, a perfect representation of the path forward. Just like this road, my exploration of data, creativity, and innovation will continue, full of twists and turns and exciting opportunities. This is not the end, but rather the beginning of many more individual projects that aim to inspire and bring more impactful results. With the knowledge gained and the determination to push boundaries, the road ahead promises to be even more rewarding. Stay tuned for what's next. From fresh ideas to innovative projects, there's so much more to achieve and share. Let's keep exploring, learning, and building because the horizon ahead is as promising as the sunrise in this image. And now, as I conclude, it's time to express my heartfelt thanks to everyone who supported and encouraged me on this journey. Let's transition to the final slide endless gratitude. As we approach the conclusion of this journey, my heart is full of gratitude. This slide represents a tribute to the unwavering love and support of my parents. It features an image that beautifully captures the essence of encouragement, care, and strength. Qualities my parents have shown me every step of the way. Mom and Dad, this moment is for you. Your belief in me has been my anchor during this journey. When challenges arose, you were there to lift my spirits. When self doubt crept in, your words reminded me of my potential. You didn't just support me, you empowered me to succeed. Mom, your care and understanding were the claim in my storm. You always knew exactly what to say to keep me focused and motivated. Dad, your guidance and belief in me gave me the strength to overcome every obstacle. Together, you have given me the most priceless gift, a foundation of love and trust that I could lean on throughout this journey. This project is a reflection of your encouragement and sacrifices. Every late night, every moment of frustration, and every small victory, none of it would have been possible without your constant presence in my life. Thank you for being my greatest supporters and my pillars of strength. Your encouragement wasn't just words, it was the driving force behind every step I took. I dedicate this achievement to you, both with all my heart. As I conclude, I want to say this. Everything I achieve is a reflection of your love and belief in me. Thank you for being my parents, my mentors, and my guiding lights. This accomplishment belongs to all of us. Thank you.